The two operations that we're going to do with sets are the AND operation and the OR operation. In one word, the AND operation is the intersection of two sets or the overlap of two sets, while the OR operation it's the addition, in a way. It's in a way the addition of all the elements that belong to either one set or the other, or on both sets. So for example, okay, let's look at these definitions first. Union and intersection of sets. So those are the two operations we do with sets: union and intersection. So union of sets, and remember we used this little symbol before that looks like a U to connect two intervals for the example I made up at the end of the previous set of exercises. Well, what is this about? Well, the union of two sets A and B, denoted A, looks like a U, A, U, B, is the set of elements that which are in A, in B, or in both A and B. All right? As opposed to the intersection, which looks like an N. It's not an N, it's just it means intersection. What is this about? What is this about? Well, the intersection of two sets A and B, which is denoted, well, actually let me do some highlight. Let me highlight some key ideas, the notation especially. A intersection B is a set of elements which are in both A and in B at the same time. All right. For example, let me make up an example. Like some of you might be are in this class and at the same time are in an English class. So math. Okay, I have a list of names here. Well, I don't want to write the names here because well, I don't want to record this. So for example, number one, we have a couple of sets, set A and set B. Okay, so set A is a list of numbers, -3, -2, -1, 0, 1, and 2, and 3. And set B is just a few, or 0 and a few even numbers, so 2, 4, and 6. I would like to start with part B. I think the intersection would be a lot quicker and easier to do. All right, so me open curly braces, that's the notation for it. And well, let's find out what numbers are on both, only the ones that are on both. Well, we can see -3 is in set A, but it's not in set B, so I'm not going to consider that element. The number -2 is not in set B either, and so it's not -1. However, what about 0? Is 0 on both? Okay, I'm going to write down 1, 0, comma. Okay, 1 is not on set. It's not in set B, so I'm not going to write it. And then the number 2 is, and I think that's about it, because the number 3, the first set goes all the way to the number 3, and well, here 4 and 6 are not on both sets. All right. So that's the intersection of both. Now, let's look at the union though. Okay, so for the union, I'm simply going to write all the numbers that I see on both sets A and B, however, without repeating any instances of them. So for example, -3, it's either here or on both, it doesn't matter, write it down. -2, -1, 0, 1. Okay, 2. However, 2 appears on both sets, but we need to write it only once. That's the same thing I did with the 0. I just wrote it once, even though it appears on both sets. And what's the next? 3 and 6. Oh, 4 and 6. All right. So again, union is all of them on all that appear on either one or both without repeating, and the intersection is just the only ones they have in common, all right, or the overlaps. Okay, the overlap thing, we're going to see it when we do some of the examples when shading some of them. However, how about we take a break and we do the inequalities when we get back to this.